Well, the Interior Provincial Exhibition is BC's largest agricultural fair. It's been around for now, this is going into our 112th year. So in 2010, we just finished our 111th. An amazing fair in a small town of British Columbia. We have a population of about 10,000 people, and our fair generates about close to 160,000 people. So just an incredible fair. Very much a family affair. We love all the things that go on at the event, from showcasing your animals to putting your baking or canning in and promoting it at the fair, to well over 200 vendors that help sell their products or services. We have lots of great entertainment to entertain the 160,000 people that come. BC's West Coast Logging Show, absolutely awesome event to attend. The mini chuck wagon's a absolute fan favorite. We will get close to 4,000 people at each of those shows throughout the day, and it's just an amazing event to see the mini chuck wagons coming from Alberta. With the influx of with that many people coming through our amazing fair, we produce a lot of garbage, and our whole mandate and opportunity in the future is to try and limit the amount that we take to the landfill and try and educate more consumers on what they can do, whether they're at the fair or when they go back home, on how they can reduce that. So that's definitely one of our mandates moving forward, is to lessen that impact. And I think it's something that comes up in a lot of the fairs across North America, and they're trying to do the same thing in their own way. And we just want to try and make a big dent in that next year and the years to come.
I have been a volunteer with the IPE for a number of years, and this year was voted as a director. Part of the duties of that directorship was to sort of chair a greening committee, and that is sort of entails recycling, composting, and that. We have had a recycling project for many years, but there has never been a composting project. And what that would entail is collecting all the food waste and paper products, plates, cutlery produced at the food court, and disposing it in a way that it would not have to go to the landfill. Sort of discussed a number of ideas, a large composting pile. That didn't seem feasible because, it's not a very environmentally safe way of composting. So we thought we would do barrel collection. So that's kind of where we headed, is finding barrels where we could collect the food waste and then have it disposed of at a place where it could be composted. There is a company in Armstrong called McLeod's Byproducts. They currently do composting there. They collect it from homes, businesses, restaurants, and that sort of thing, and they compost it at their facility and they sell it. So they were very willing to collect our compost product and take it to their facility to make it into compost. For this year's project, the food waste did have to be separated from the cutlery. It's because of the process that we had chosen to use this year. We were using an anaerobic process. We wanted to try this as a pilot project, and the product was provided by Brightland, which is a company in Vernon. They wanted to try this. It's something that's new to this area. So we thought it would be a great idea to try this anaerobic process, but it does require separating. It has to be specifically food. And so it did require a lot of volunteers to help separate it. So we did manage to collect 21 barrels. They were supplied to us by another volunteer at the fair, and they were white barrels. So we thought that would be great because then they're different colors. The garbage barrels are black, and we thought the white would be a very good color to differentiate between the garbage barrels. So I had signage made up for the barrels. I had also signage made up that we could display around the food court area to let people know that we were encouraging them to dispose their food waste and paper products in these barrels. We realized partway through the fair that the public was having a difficult time identifying the barrels that they were to put their food waste into. So we kind of had to encourage them with volunteers showing them which barrels were for recycling, compostable products, and the garbage.
Our company's been very involved with sustainable practices here in Vernon, and we're very keen about working with our community resources, especially the landfill issues, because we have a very limited spot to use our landfill. And when it's full, where does it go? So everything we can possibly do to reduce the amount of waste going to the landfill is a very good thing.
My name is Dale Danilenko. I'm the Recycling and Disposal Facilities Operations Manager for the Regional District of North Okanagan. As RDF Operations Manager for the Regional District, I'm responsible for operations at all of our landfill sites and our transfer stations, which include the facility we're at this morning, which is the Armstrong Spallum Machine Recycling and Disposal Facility. It's a typical day at the Armstrong RDF with a whole wide variety of municipal solid waste sitting waiting to be buried forever. The primary objective of the RDNO's waste reduction programs is to extend the life of our landfill facilities. What you're seeing here is the landfill component of the Armstrong Recycling and Disposal Facility. Material that ends up here, as I said earlier, is buried forever. It's taking up space, valuable landfill capacity, and if you look around, there's a fair amount of material that did not need to be buried. So our objective is to divert as much material from landfill as we possibly can. Items such as wood, metal, recyclable materials such as paper, cardboard. You look in these loads that have been dumped this morning and you can see that there are fairly substantial amounts of those types of material in the loads that will be buried that did not necessarily need to be buried had the waste generators chosen to take the time to divert these materials from disposal. The Regional District of North Okanagan provided a small amount of funding in support of the Bokashi pilot project at the IPE in an effort to determine the feasibility of composting of small volumes of organic food waste. Our 2005 waste composition study showed that 40% of the waste stream was divertible organic material. So as you can imagine, if you diverted 40% of the material, you would extend the life of each of the facilities, because each facility has a finite capacity, and the quicker you fill it up with whatever type of material you choose to landfill, the quicker that facility is used up. We would encourage people to take responsibility for the waste they generate and to understand that everything that they throw in the garbage is buried and it's buried forever. And everything that they send to landfill takes up valuable landfill space. It's expensive to close landfill facilities, it's expensive to establish new ones. So the longer we can make our current sites last, the better off we will all be. And it's a choice that people need to make to think about their consumption patterns, to think about the waste they generate, and to do the right thing, to minimize the amount of material that they do send to landfill, to maximize the amount of waste of their waste that they divert, either to composting, to recycling, to reusing. There are all kinds of options and choices out there for people to do the right thing to reduce the amount of waste they generate. We have areas for organic yard waste. People are permitted to bring in organic yard waste, or yard and garden waste as we call it, free of charge. 6 weeks in the spring and 6 weeks in the fall. The disposal fee during the remainder of the year, or the recycling fee during the remainder of the year for yard waste, is very low at $20 a ton. We grind that material and use it for on-site purposes, or it is sent to Tolko Mill to be used in their cogeneration facility. The RDN also encourages residents to practice backyard composting. Every 2 years we have a subsidized composter sale where we sell earth machine composters at a reduced fee to residents in the North Okanagan. We hope to encourage people to divert organic waste from their waste stream by composting it in their own backyard. If you look at a typical landfill site 20 years ago compared to today, there's much less that is being buried. We do have very successful programs for cardboard, for paper, for plastics, for wood waste, for metal, for yard waste, but we can still do better because, as you can see, there is still much more that can be removed from the waste stream and recycled and reused. So the 3 R's of reduce, reuse, recycle, we can do a better job and we can do more. And it's a case of people changing their behavior and attitudes towards the waste they generate.
I volunteered to work on the IPE Bokashi project to help with the environmental approvals that were necessary in order to put the fermented material on the farmer's land. This project is really important because it addresses a number of problems and provides really great environmental solutions. The first problem is insufficient nutrients in farmers' lands, in the fields. The second problem is food waste that is unnecessarily filling up our landfills. And in the North Okanagan, food waste is approximately 25 to 40% of the waste going into the landfills. So these are two problems that we can attack and help solve with the Bokashi fermentation method. So when I heard that Dave Weatherall of Brightland was interested in spearheading a Bokashi project using the waste from the IPE, I quickly contacted Dave and volunteered my services to help with the environmental approval process. This process is very important because the food waste after fermentation ends up on a farmer's field, and the Environment Ministry Environmental Protection Branch is particularly concerned with ensuring that there is no adverse effect to the agricultural land. So I worked closely with Lorena Kloppenberg representing the IPE and with Larry Green from Bokashi Cycle, who put together the protocol that we would use for the project. And I became the study coordinator for this project. We need to ensure that there is no contamination of the food waste with plastic, styrofoam, or any other undesirable materials. The second step in the process is preparing the food waste for the fermentation. So that involves shredding and inoculating the food waste with a special material that will speed up the decomposition of the food waste. The third step is sealing the inoculated waste in barrels and leaving them for a period of approximately 2 weeks. After that time, the material has decomposed partially and is ready to be tilled into a farmer's field.
Basically, the rule of thumb is 5 pounds of culture mix per barrel. So it's really easy. And you just spread it all over just spread the powder on it. Because when it runs through the shredder, it's all going to get mixed uniformly anyway. So it's going to be kind of fun. It's going to be noisy. It's going to throw possibly a lot of stuff against that wall. This is the experiment. It's not exactly the shredder that we choose as a first choice, but it's a good example. Here in Armstrong, we're doing a pilot project where we're taking approximately 2 tons of waste material and we're mixing that with a special powder inoculated with microbes. It's a wheat bran molasses-based powder that has microbes embedded in it, and these microbes are specialized so that they will process that food waste in a form that it can then be rapidly mixed in with soil and feeds the soil microbes. And what's valuable about this process is that unlike composting, which oxidizes and causes massive amounts of the material to end up as a gas escaping into the air, fermenting under acidic anaerobic conditions, which is pickling your food waste, alters the form of the food waste to a kind of material that can be easily then processed by soil microbes. So the advantage of the fermentation process is that it's very short, typically about 7 to 10 days. And when that process is mixed with the soil, within the next 7 to 10 days, microbes in the soil, which are literally starving, will rapidly feast on the banquet that you essentially prepared for them. Now, fundamentally, most people realize that difficulties in raising crops and using farmland are related in part to the lack of nutrients, but also very much to the depletion of microbes in the soil. And that's happened because we use a lot of pesticides and fertilizers. However, if you feed the soil with the right nutrients, those microbes can rapidly reestablish their population, and that makes it a truly sustainable process in agriculture. If we can take the food waste that's generated in the homes or at restaurants or in the community and then rapidly convert that to a form that can then be plowed or tilled into the field and then is subsequently within the next 10 to 15 days processed to a form where we are able to then plant over that soil, we've got a truly sustainable process that I think ultimately will be proven to be far superior to any of our current methods. So that's what the pilot project is at Armstrong. We're working with the IPE, taking about 2 tons of the material. What it's all about is rapidly taking food waste from the table scraps or from the restaurant, processing it simply in a short time in a closed container, specialized fermenters. It's entirely scalable, and then placing it into the fields and plowing it so it can be used for farming. What we hope to do is, with this pilot study, which will be complete within the next couple weeks, accumulate a sufficient amount of data to get a summary report to the environmental officers who will be looking at this with interest. And I will say that I'm very impressed that in Canada and here in Armstrong Vernon, we've found people that have been thinking ahead about this problem and understand that it's important to look at alternatives. One of the interests that I've had, and I'm very pleased to see that there are others in the community, for example here in British Columbia, that are thinking far ahead, is how to get rid of our waste problem. And by that I mean the trash, the organic waste, the food waste that is accumulating and being shuttled off to the landfill or possibly sent off to a composting site. A couple years ago, we really began to think more seriously about this problem, the fact that we're running out of space, that there is an alternative, better way of handling food waste, and it really comes down to what we refer to as sustainable agricultural practices. The process of putting the food scraps and the food material into the landfill or sending it off to a compost pile has been long known, But very few people know that there's a better and superior and far more rapid, efficient way of processing this food waste by, instead of putting it into a compost pile or into a landfill, fermenting the material. Basically what we're going to do is pickle the food waste. We've been actually doing this process for a couple years down in Hillsboro, Oregon, in a process where we take all of the food waste from the Bon Appetit restaurants, which serve the Intel campuses, and we process and convert that within 7 days to a fermented product, pickled food waste, if you will. We spread that on the field, lightly till it in. Within the next 7 to 10 days, it's gone. If you dig for it, you won't find it. And what we've observed, and what is well known, is that that soil now is not only enriched in nutrients, but also in microbes, and we're able to continue a cycle, making the land far more productive. Cities and municipalities could do this, and you might ask the question, well, why aren't they doing it right now? What's kind of interesting about that is, well, in the United States and Canada, not many people, and certainly the officials in states and provinces, those people that pass the laws on how to handle food waste, certainly haven't heard about this. However, what's interesting is in many other parts of the world, for example, Asia, New Zealand, Australia, and even in the UK, this process is well known and being put into practice. In some places, it's already, for example, in New Zealand, in operation with city municipalities. The other thing that I should also mention, and sometimes this is a question that comes up, people are concerned about pathogens in the food waste, and that's an appropriate concern. We've all heard about Salmonella and E. coli, and sometimes it's mentioned, for example, in composting that it's important to get the temperature elevated up to 165 degrees Fahrenheit. It's important to heat it for a sufficient period of time to so-called sterilize and get rid of the pathogens. Anyone that thinks about this for a little bit will realize that that temperature is not sufficient to sterilize. It may be a form of pasteurization, if you will, but your safety is not assured just because you get it to that temperature. An advantage to acidic anaerobic fermentation, which may be surprising but is well established in the literature, is that some of the breakdown metabolites or chemical products that come out of it are highly toxic to E. coli and Salmonella, some of the major pathogens that we experience in our environment. And it's so effective that these small molecules that are produced are in fact used in the food industry to stabilize food, to prevent it from getting contaminated. So if we think about this for a moment, it really makes a lot of sense. If we can take organic waste, seed it with the right culture mix, put it in a fermenter, rapidly, taking very little land and very little time, get it back to a process that can be fed to the soil, and in those simple steps, very simple steps requiring little machinery and little work, we can also get produced metabolites that are toxic to the pathogens. We don't really need to heat the material up, we just simply need to make the environment so hostile that they can't survive. Yeah.
I've been farming for 20 years on this property. Mostly it's a hay farm, but I do a fair-sized market garden just to keep myself out of mischief. I'll be providing a 20 by 20 square foot space which will accommodate 2 tons of composted food waste from the IPE, the Armstrong Provincial Exhibition. I think this project has some importance because it seems an awful shame to waste compostable material that could well be put back into the land and utilized in a productive way. Right now we're harvesting corn and cabbages, onions. That's the 3 big things that I grow in any amount. This is a 20 by 20 grid that they've laid out, and they're going to put 2 tons of composted food waste on this. Then I'm to till it in lightly with my tiller.
Here we are at McLeod's for our final day of shredding the food waste from the IPE. So let's go see what we've got. So this is all food waste. Some of it's from vendors. So you can see onions they didn't cook up, French fries they didn't fry. A lot of corn, coffee grounds, some more potatoes, and then some food waste from people at the fair. So you can see some stuff there. Those little forks you see, they are aspen ware. They're wooden and they're made of completely organic, biodegradable material, so they will compost really well. So the process we have to follow is we have to weigh this material. We have to record the weights. Then we have to dump it out on the floor in this area, and I have to add some Bokashi culture mix, which has all the little microbes and things that digest the food. And then what we do is we feed the food a little bit at a time into that shredder. And you can see we aim the shredder at the wall, so we just blow the stuff at the wall. And then we shovel it into these barrels. So we weigh it, dump it out and inoculate it, shred it, put it in the barrels. I think we have 4 barrels here from vendors. And then we have 1, 2, 3, 4, 5 barrels of pretty clean separated waste, and then 3 barrels of garbage. So that's food waste plus paper products plus plastics and so on. And we're going to deal with the food waste and put it into the Bokashi process. 22. It went very well today. We processed close to 400 kilograms of gross weight of food waste and filled our 5th fermentation barrel. So our work is complete on this stage of the project. The food monitors in the food court did a great job of keeping plastics and paper plates and cardboard containers out of the food waste from that area, as did the vendors who provided us with their excess food waste. A little bit of a challenge today in the cardboard and other non-compostable items that showed up at the last minute. Today's waste we had a lot of corn cobs and corn leaves. An unbelievable amount of corn is consumed at the IPE, and it's all local, which is great. We also had a large quantity of unfried French fries and unfried onions, some coffee grounds, lots of coffee grounds, coffee filters, and a terrific barrel of Mexican food waste, including guacamole, sour cream, tacos, and salsa, to add a little color to our job today. Now, one of the things we were able to do today was open up a fermentation barrel that had been sitting here for 4 days. And we confirmed, as predicted, that the smell from that food waste that was fermenting with the Bokashi culture was a sweet, not at all unpleasant odor, quite a pleasant odor from that fermentation process. The job that we were doing here in the pilot project was not using all of the equipment exactly as it would be if this were a commercial operation. Brightland very kindly loaned us a small chipper shredder to use to prepare the food before loading it into the fermenters. And that small chipper shredder meant that we had a lot of labor to do to actually feed it and then shovel the food waste into the blue barrels fermenters when we were finished. The normal commercial project would use a much larger shredder, which would drop the food waste right straight into the fermentation bin and cut out most of the labor associated with this project. I'm feeling very satisfied that we got 5 barrels for our pilot project. In total, we will have processed between 1,000 and 1,500 pounds of food waste. In contrast to aerobic composting and vermiculture, the Bokashi process can take a much wider variety of food wastes. For example, meat products and salad and cooking oils. Meat products, of course, cause tremendous problems with compost because of the attraction of rodents and vermin. And the salad oils and cooking oils are problematic with the worms in vermiculture.
We got involved with the vermiculture program where we developed a worm composting setup, and we've developed several of those right up to commercial sizes. Vermiculture is nice in that the final product, the tea and the worm castings, can be immediately used and put onto plant material in and around the house and even at home. And the worms are able to naturally consume all the vegetative matter, but then you bump into meat waste.
We tried a project with worm composting, and it worked well for a little bit of reducing our impact on the environment, but we weren't able to do it on a big scale.
My name is Sonia Straight. I'm a teacher at Okanagan Landing School, and I have several students with me who I have taught a couple of years ago and who are still in the school. This is Larissa and Landon and Ailish and Maddie, and we're all here because of the compost bin.
Red wiggly worms. They eat all the compost, like apple cores, and it makes good soil. Their bodies make good soil. So
we've grown a pumpkin plant, and we will be planting a square-foot garden.
Yeah. We put paper shreddings, and then we put a little bit of soil to help them, and then we put buckets of water on, like 3 buckets of water every week or a day, and then the worms help by processing more soil and eat the banana peels and orange peels and all the fruit that we put in, and then it turns into soil. Okay, I love you,
Once we get through this trial process, it's been done elsewhere. We have to prove it in our own community so that people are satisfied within our own community that yes, it does work, it does exactly what it says it's going to do. And then we'll be able to move it forward to the next step. The Bokashi cycle has gone through much research. It's now stabilized, it's able to be provided on a long-term basis. And so we can take the products and move forward and expand it up into a complete closed loop community system.
So Bokashi was invented in Japan in the 1980s. It's a combination of lactobacillus bacteria that work in conjunction with each other to provide the complex microorganism to ferment organic wastes. Because it pickles and ferments, it doesn't attract fruit flies, it doesn't smell bad, and because you're fermenting it, you can add fish or meat to it because it doesn't putrefy. Take your food scraps from your kitchen, put them in the bucket. For every 2 or 3 centimeters of food waste, put in a handful of Bokashi, and then compress the food waste that's there, and keep layering it as you're filling it up. And when the bucket is full, top it off with a big layer, and then let it sit 10 to 14 days for it to finish off. At that point, you can begin a second bucket, or you can simply wait until your first bucket is ready. And then put it into the ground, and it breaks down really quickly. Worms love it, and the material you get out is great for the garden. Bokashi has great potential in an urban environment as long as space is available for the cycle to finish. And that's the important part. A lot of people in Vancouver, or in urban areas live in apartments, so when it comes to composting, they feel bad that they're throwing their stuff out. If you can get access to a compost bin or some open ground or a community garden plot or something like that, you can solve that. Most of the time, I just pour everything into the compost bin. The liquid, the food scraps, it does the job.
Another situation it handles is increase the carbon cycle content, the carbon content of the soils that you put it in. So that helps to replace the fertilizers that people put on that are synthetic fertilizers and replaces them with a fully balanced, fully complemented, natural minor element mix that goes into the soil. My dream is to take the food waste from our restaurants and our commercial facilities, take them to a central location, have them processed, put them through the composting process, harvest that soil, and have people use that to grow their own food and produce within their decks, their balconies, and their backyards.
Through my work on projects in the North Okanagan, I have come to start learning about anaerobic digestion and the decomposition of various types of waste to provide beneficial material that can be used to enrich the land. So it's just a growing interest of mine from both a community and environmental perspective and from an agricultural sustainability perspective. It was terrific to have the help of McLeod's byproducts with the transport of the waste from the IPE to their processing facility in Spalumsheen. They also helped us transport the fermented waste out to the Weirs farm. Today we are waiting for final approval from the Ministry of Environment, which I'm going to follow up on in just a minute. We are going to open up these barrels, take photographs of the contents to show what the material looks like after a couple of weeks in the barrels, and then we are going to sample the liquid from the barrels. so that it can be sent to a laboratory for testing. Once we get the Ministry of Environment final approval, then we will spread this fermented material on the land and till it into the ground. 10 days after that, we'll take more samples, and that will be the end of the project. Whoa. Yeah, I mean, it just looks, now it looks
Hayish.
hayish, yeah. The liquid must be way down.
Yeah, have liquid at the bottom.
Yeah. Yeah, have a look, Doug.
Yeah,
So it looks quite dry. It doesn't smell bad, does it?
No, it smells a little bit fermented.
Mm-hmm. This is working. Well, today was the final step in our process where we opened up the barrels of fermented waste, took our last samples that we needed, and then incorporated all the fermented solids and liquid into the field behind me. So we spread the material evenly across the field, and then Doug Weir, the farmer, tilled it into the ground to cover it with soil. We took some samples this morning of the liquid from the barrels, and you can see it's a brownish liquid, a little bit of sediment at the bottom. So this is a concentrated fertilizer. We're going to have it tested in a lab to find out the precise components. But this is what's called the tea from the fermentation process, and it provides lots of great nutrition for the soil. So when we get this liquid tested in the lab, we're looking for concentrations of things like nitrogen, phosphorus, potassium, the usual positive things that you want in fertilizer. And we are also testing for heavy metals and other nasty things that you don't want to see in the fertilizer. So we expect to find a good concentration of the positive elements, and we do not expect to find any heavy metals or any bad material in this. And we also will be testing for fecal coliforms to make sure that the material is suitable for growing food. We've also drawn soil samples so that we can compare the soil before the fermented food waste has been added. And then we will draw soil samples in about 2 weeks' time so the lab can compare the after samples as well. And again, we expect the soil after the fermented material has been incorporated. We expect the soil to be greatly enriched and suitable for a terrific crop for next year. So the process went really well. The material was quite wet and heavy, but still sweet smelling and not unpleasant at all. Now the material is going to stay covered by the dirt for 10 to 14 days, and at the end of that time we'll do some more sampling, but we expect all the fermented material to just have been incorporated into the soil, and we expect it basically to have disappeared. And Doug Weir, the farmer, is looking forward to how big his onions are going to be next year with all of this great fertilizer in the soil. In the province of British Columbia, we have a number of regulations that apply to organic matter recycling and the application of off-farm organic matter to agricultural land. But at the current time, we don't have anything that specifically mentions or applies to the Bokashi process. So we were very fortunate to have the cooperation of the BC Ministry of Environment, Environmental Protection Branch in Penticton, and the Agricultural Land Commission in assisting us and supporting us in this pilot project.
We have found the higher levels of government to be incredibly supportive because they're all looking towards alternative methods to deal with the waste that we are generating as a society. They are cautious, they're incredibly supportive, but they're cautious to make sure that all the protocols are followed so that there is no way that the public or private lands will be endangered in any way. So the Ministry of Environment, I give them full marks for their support and cooperation and their caution, because they were very professional, very thorough, and very supportive all at the same time. One of the main levels of government locally, with their solid waste management, they have set aside a budget for research and development of different ways to deal with our wastes, and they have actually financed the pilot project, and that is incredibly encouraging.
This was a very interesting project to be involved in, and it has been a tremendous experience. I think the most gratifying and interesting part of this project has been the support of individuals in the community. Everyone that I have spoken to is excited about the possibilities of this treatment of food waste. People are very interested in reducing our need for landfills and are keen to find out what they can do to help.
Well, I think our composting project is an evolution of the things we've wanted to do over the last 3 years. We started 3 years ago with a green expo, trying to attract more environmentally friendly products and services to showcase themselves at the fair, and it's kind of evolved from there into this year. We also used Aspenware cutlery, and it worked so well and they gave us 1 million pieces of product to give to all the food vendors so they could use with consumers instead of using plastic or styrofoam. And that was just an outstanding progression this year. And each year we want to try and figure out a way to make it better.
I think not all projects are suitable for every venue. I think that whether it be a music festival or a fair or some sort of gathering, they would have to do an evaluation of what would be generated by their activity and sort of decide what would work best. I think it's definitely possible for every type of venue, but it does take a committee, as Brian said. It isn't something you can say, oh, that'll work for me just because it worked for this group.
We are trying to figure out the best ways that we can impact that environment, and we are open to all kinds of ideas. We'll try them. If it doesn't work, we'll try something else the following year. If we can have 10 projects on the go and it all makes sense, that's something that we want to do to continue having a great fair. We just finished our 111th year, and we want to go for another 111. So we want to find ways to do that, and especially the whole aspect of educating the consumer or the public on ways they can do it.